or he doesn't show. Okay, now we're recording. There we go. We're live, coming from you, right from Thunder Alley. Oh, great. Come on. Okay. So, it sounds like the first part of this is going to go real quick, because apparently we talked about it last time, but just as a quick recap. Most calculators only do natural log and common log. Most calculators only do those two. So just real quick, so you get used to using your calculator, do this for me. Evaluate this for me. Just so you can practice using your calculator. Go. Evaluate log 1000. Come on. You need to understand how your calculator works. So on a test, I can't explain it to you on a test. You just got to know how it works. What's the log of 1000? It's 3, right? Your calculator should tell you that it equals 3. What most calculators can't do would be when we change the base. Like, what if I asked you to do the log base 5 of 125? Most calculators, especially the ones that you're using on your phones, and this also does equal 3. Now, some calculators nowadays, if they're new enough, can actually do this if you know how. So mine can do a log base 3 of 125, log base 5 of 125. What the crap am I doing? Log base 5 of 125, and it equals 3. But what if you don't have a calculator that does this? Can you still evaluate that? The answer is yes. Did we talk about this formula last time? No, this is what's called, so write this down. This is called the change of base formula. Change of base formula. What this does is it allows you to do stuff like this on any calculator, even like your phone calculators or your basic scientific calculators, if you know the change of base formula. It's 10.4. Now, for some students, it's hard to see the significance of this formula, but it is pretty significant. Give you a chance here to finish writing. Here's what I'm talking about. You guys answer this question for me. This logarithm right here, what's the base of that logarithm? B. It's a log base B. But both of these logarithms here and here, what's the base of both of those? Log base 10. That's the significance. Most calculators can't do a log base B, but your calculator can do a log base 10 pretty easy. So for those of you that aren't able to change the base of the logarithm, check this out. The log base 5 of 125, if we use this formula, it's the logarithm of what's inside divided by the logarithm of the base. So it's going to be the log of 125 divided by the log of 5. Now you can use your calculator. Type in just a normal logarithm of 125, close parentheses, divide that by the logarithm of 5, close parentheses, and hit enter, and it tells you the exact same amount, it equals 3. So all of those problems I had you do on last time's assignment, 8.2, where you had to evaluate, some of them were real tricky. Like this one here, all of my students have been asking about this problem. This is from 8.2. It was the log base 3, I think, of 1/9. That was one of your assigned problems, and you're supposed to evaluate that. And you're supposed to do it by hand, which can be done. It's a little tricky. The intent is to change the 1/9 so that it has a base of 3. How can you make 3 turn into 1/9? Well, it has to have a negative exponent. What negative exponent is going to change 3 into 1/9? What's the relationship between a 3 and a 9? How does 3 become 9? What exponent? So it's going to be -2. And then you cancel here and here, so the answer is, that's how you would do that by hand. And that's what I taught you to do last time. But what I'm showing you now with the calculator, is this necessary really to do anymore if you can use your calculator? No, it's not. Use the change base formula. Do the log of 1/9 divided by the log of 3, and it will give you the same answer, equals -2. Yeah, the hard one press. This is pretty cool, Gabriel. Nothing, huh? Well, take a look at the worksheet I just gave you. Come on, quick. Worksheet I just gave you, except for you. Let's see. The first 10 problems are just evaluating problems. And the intent now is that you practice using your calculator to evaluate rather than by hand. For example, problem 1 on your worksheet is the log base 6 of 216. The intent is to use your calculator. You're going to do the log of 216 divided by the log 6, and it equals 3. I'm going to pause this. You guys take a moment, try to do a couple of these before we move on. Okay. Here's objective 2. The laws of logarithms. It's a weird name. Yeah. Should be. Aren't there answers?
Yeah.
Pretty important topic, this one right here. This is usually, I'm not saying it has to be this way, but usually on the test that we're going to take next week, this section of problems is where students tend not to do so well. And it's simply a matter of lack of practice. It's not because this is more difficult. Students choose not to practice it, and so they've also chosen to get a bad score on the exam. So practice this stuff. So to expand a logarithmic expression means you take a logarithmic expression that contains one logarithm, you expand it out into multiple logarithms. Condense is just the opposite. You take something that has a few logarithms and you put them back together into one logarithmic expression. There are reasons for doing both. For what we're interested in, this is going to be most useful for us in solving equations. You have to condense to solve equations. This right here, expanding, for those of you that plan on taking calculus later on in your lives, you'll be doing maybe a little bit more of expanding logarithms. But anyway, here's rule number 1. Laws of logarithms. Thou shalt have no other logarithm before me. That's rule number 1. There's actually rule number 1. It's called the product rule. The product rule says if you take a logarithm, now what does product mean when I say product? In mathematics, what does product mean? Multiplication, exactly. So notice I'm taking one logarithm of a product x times y. If you expand that, you get two separate logarithms separated by a plus sign. And that's really the important connection. If you're taking the logarithm of a product, you expand using an addition right here. You add two separate logarithms together. Now the reason I have this arrow way up here that says expand is if you go the other way and start with two separate logarithms, you can put them back together again. That's called condensing. Condense means to make smaller, expand means to make larger. So there's property 1, or law number 1. I don't know why they call these laws. It makes it sound so formal. Law number 2, honor that logarithm. No, almost the same as law number 1. The connection you need to make here is if you're taking the logarithm of some kind of a fraction, then you separate the two logarithms using subtraction. Subtraction is related to a fraction. Multiply is related to addition. So you can expand and condense. We got that one written down? All right, last one. Now let me explain. Everybody stop writing for just a second, because I don't want you to miss this on this clarification here. What did we talk about last time with logarithms? What does a logarithm do? A logarithm cancels bases, right? A logarithm cancels bases. But only some students get that so drilled into the mind that they think, okay, this logarithm is going to cancel that base. Is that the case here? This logarithm doesn't cancel that base because they're not the same. They only cancel bases if they're the same base. But there is still something you can do. If you take the logarithm of something that has a power, you can take that power and just move it down in front of the logarithm. So you're not technically canceling the base, but you're still changing it so it doesn't have an exponent anymore. Well, hello. Let's practice. We'll start off really easy, and then some of the ones on your homework are a little challenging. We'll probably have to do some of those together before I leave, but this first one's pretty easy. Log base 2 of 5x. The log base 2. This one's actually so easy, it's embarrassing. The directions specifically say to expand. So what you have to consider is what is it you're taking the logarithm of. Here it's a product. 5 times x forms a product. Which law does this resemble? Law number 1. If you take a look at law number 1, it says you expand by creating separate logarithms, all separated by a plus sign. In this case, it's going to be log base 2 of 5 plus log base 2 of x. That's all you leave it. Just expand it and leave it. Now I know it doesn't seem like there's much point to doing that, and if you're just going to expand it and leave it, there really isn't a point. The point today is just practice. You'll start using this in more detail the further you go in mathematics. Right now, you're just learning the basics. You have to learn how to add before you multiply, and you have to learn how to multiply before doing double-digit multiplication. So you have to build upon things. We're just building some basics here. Try this one. Quick looking at the answers. Actually, we're doing this one together. Let's work on this one together. Yeah, and that's what you're going to see most of the time is a combination of these laws. You very rarely just use one and that's it. This is a combination of a product right here, and it also has a power. So, usually, you guys listening, 99% of the time, you'll save all of these powers for the very last step. So I'm talking about property number 3. usually what you do at the end. So we should expand this product first of all. How do we expand that product? With addition or subtraction? Addition. It's going to be log base 3 of x plus log base 3 of y to the third. So we've expanded that product using addition. Now we can apply log number 3, which says if you're taking the logarithm and the bases don't cancel, you can still do something with that exponent. Where does it go? It goes to the front of which logarithm? The one to which it's connected. Yeah, it has to go to the front of that logarithm right there. It can't go to the very, very front. The final answer is log base 3 of x plus 3 log base 3 of y. Now I want to show you a problem that's almost exactly the same as this one, but the difference is important enough that we have to go about it a different way. So take a look at this problem. You see the difference there? The 3 is on the outside of the parenthesis versus inside. That's pretty significant. There's actually 2 ways, and both ways are fine. I don't think one way is better than the other. I really don't. Let me show you one way. And then you guys decide which way you like best. If, you guys listen carefully, if the exponent is on the outside of the parenthesis, you can apply that exponent to the terms inside the parentheses. So you could rewrite this as the log base 3 of x to the third times y to the third. And now that it's written like that, isn't it almost exactly the same as this one here? Just expand the product using addition, and then move each of those exponents to the front of their logarithms. So I hate to combine steps here, but we're running short on time. So if you think you can do it, what's the final answer going to look like? 3 log base 3 of x plus 3 log base 3 y. Exactly. There's one way to do that problem. This is actually the way I would recommend. Simply there's fewer chances of making a mistake. But the other way is just as easy and just as quick. Let me show you. Instead of distributing that exponent inside, I guess listen carefully, this only works if the exponent is on the outside of the parenthesis. Remember how I said property 3 you usually only do at the end, usually? This is the one case where you can do it at the beginning. If the exponent's on the outside, you can just take that and move it down to the front, and you have 3 times the log base 3 of xy. Now you can expand, but you have to make sure that this 3 right here multiplies the entire expansion. So it has to be 3, and you have to remember to multiply the full expansion, log base 3 of x plus log base 3 of y. Do you see why I had to put parentheses there? If not, the 3 would only be multiplying that first logarithm, but now you have to distribute it, and you get the same answer. Let's do a couple from your worksheet, because these get a little funky. So get that out. Let's take a look at, oh my word. Well, we'll do 13 in just a second. That was super crazy. Let's do 15. Yeah.
Does n mean the same thing where on the second
Let's take a look at 15, guys. 15 is log base 6 of a to the third times b raised to the second power. This resembles the problem that we just finished. What do you suggest?
You always choose one of the three.
Well, you can't just choose around one of those three properties applies here.
No, I know, but I can choose every time since we can be one of those.
This is number 15 on your worksheet. Does it matter whether or not this exponent is inside or outside? It matters.
My guess is number 2.
My first choice would be to do it this way. So when you have a power to a power, so this is going to become the log base 6 of a to the 6b 2 squared. Now what can you do?
That's number 1.
That's property 1. What's going to happen to these powers though? So you're still going to expand using a plus sign. This is going to be the log base 6 of a to the 6 plus the log base 6 of b squared. But you can't leave those exponents.
Where's the ln? Wait, so what do you...
What are you saying then?
So 2 log.
That 6 goes in front there. That 2 goes in front. There we go.
Wait, question.
Yeah.
What did you do after? So like, what was that whole next step right there?
This is property 3. Look at your property 3.
Oh, I thought you just took property once.
You only use properties from that list, but you can use more than one at the same time. So now property 3 applies. You have to take the exponent and go down in front. Number 18. Let's do 18 next.
Is that the answer then?
Well, once you move the 6 down and the 2 down, that will be the answer. Well, let's explain 18. We don't have time to get too far into it. So a lot of students have trouble with this right here. What is this? That, all it is a regular logarithm of the base of b. This is no different than problem 15. You treat it the same way. So I would distribute the exponents, expand it, and then move the exponents down in front, just like you did on 15. Make sense? Now, take a look at 17.
What's the ln?
Natural log base e that we talked about last time, log base e.
So what do you do on that 18? Is that it?
Same thing we did on 15. You put the exponent, you expand that using a plus sign into 2 separate natural logs, and then you move the numbers down in front. Just like we did on 15. Now what about this one, you guys? Number 17. Even though there's 3 terms, what are all of them doing to each other? They're all multiplying. So how do you expand it if they're all multiplying? You can add them all. So how many logarithms do we end up with here? Just 3 different logarithms, and they're all separated by a plus sign. And once you do expand it, what's going to happen to this 4 right here? It's going to move to that logarithm that has the z. So that one's not too bad.
Is it only, why does it only go to z? Oh, it's because
It's not on the outside, it's on the inside. So that's just a couple of those. You feeling okay about some of those? Now the ones we haven't done from that section, sorry, go back to your notes real quick. Is an example like this one. Part D. Okay. You'll have plenty of time to work on the assignment. You're going to have about 40 minutes. So put that off to the side for a second. You can't miss this one either. You can't miss this one. So, there's a lot happening here. Not only do we have a product here, but we have a fraction as well. And that's the first thing that concerns me is this fraction. We can take care of the product in a minute, but this fraction, take a look earlier on in your notes. What the heck do we do when we're taking the logarithm of a fraction? Right here. We expand using a subtraction sign now. So that's the first thing we're going to do is...
I have a question.
Yeah.
How do you, like when you choose the property, how do you go from what you have to, like, how do you expand what you have here and turn it into that?
This is what we're practicing here. So when we're using that subtraction property, you take the logarithm of the numerator and you minus the logarithm of the denominator. So this is going to be the log of x squared y minus the log of z to the fourth. You just subtract numerator from the denominator inside different logarithms. You okay with that step? But now notice what we have here. What is this? So that has to be expanded. This is a product of x squared times y. What expands a product? Addition. So this one logarithm has to split off into two logarithms. This is going to be the log of x squared plus the log of y, and then we minus the log of z to the fourth. The connection you need to make is multiplication is expanded with addition. Fractions are expanded with subtraction. Now we're just about done. Just got to move the exponents in the front. Yep. Yep. So this is 2 log x plus log y minus 4 log z.
What was that division sign? Was it multiply? Like it was multiplying y, it was multiplying z to the fourth power.
Here.
You would do it plus something. We just do the
I
same.
want you guys to try this. Is this what you're talking about? I want you guys to try this one on your own, and I'll just warn you, 99. I think every single student yesterday missed this one. It's almost the exact same thing that we did. The first thing you always do is split apart the fraction. Always split apart the fraction first, and then you can worry about splitting apart the product. So try it. I want you to write down an answer.
Y is multiplying z, right?
Y is multiplying z. Yep. I'm going to pause it here. I know that wasn't a ton of time. Let me read the answer before I write it.
Let's see if I got it right first.
The steps are to expand this, to expand the fraction using minus, right? And then what do you use to expand the product?
Addition.
Addition. So then why is that wrong? Here's the answer. Listen carefully. The answer is log base 4 of x minus log base 4 of y. So far, so good?
Yeah.
Let me start over. Log base 4 of x minus log base 4 of y minus 3 log base 4 of z. How is it minus? Here's why. And once you've seen this done once, hopefully you'll remember. Let me erase this. No.
Isn't 3 being distributed to the y though?
No.
That's because it's then it's like
The 3 is only
inside,
connected to
so
the z.
it's just to the z, but it goes outside right here to the both.
No, I know, but the y and z are together, aren't they?
But the 3 is only connected to the z.
It's like when the y and z are right next to each other, these are multiplied.
So hopefully this is how y'all started. Log base 4 of x minus log base 4 of y z to the third. Is that how y'all started?
Yeah.
Good, that's great, that's perfect. Here's where I think it got a little funky. Aren't you supposed to subtract this entire expansion? So you've got to subtract the entire expansion in parentheses. So it's minus log base 4 of y. And you still use a plus here. That's not incorrect. The problem is, if you're subtracting this entire expansion in parentheses, what happens to that minus sign? It distributes to both.
Oh, so it makes it all negative.
Makes them all minus. Except for the first one. The first one. So it's log base 4 of x minus log base 4 of y minus 3 log base 4 of z. So I know it seems silly, but it's a pretty important difference. Yeah.
If we just subtracted it and went the parentheses on.
I'd accept that. If you didn't want to distribute the minus sign, that's fine with me. Now here's a little trick, you guys. Maybe a little shortcut. Are you watching carefully? Do you see how this logarithm has a minus sign in front of it? And this logarithm has a minus sign in front. You see that?
Yeah.
Well, take a look at the original problem. Both of the terms that had that negative logarithm showed up in the denominator. Take a look at the problem above it. You see how there's only a z in the denominator? And look at the expansion. Which one is the only one that had a negative logarithm? The z.
So if it's in the denominator, it has to be negative.
And that pattern will always work. Now you notice on your worksheets some of them have not fractions, roots on them. They're not as bad as you think. They really aren't. Same as what I'm going to show you here. So we'll do this problem, and then I'll help you with the one in your worksheet that looks kind of like this one. It's just a simple little trick. Logarithms and roots don't play well together at all. They're enemies, bitter enemies. So here's what I would do. Well, before I show you that, remember back in Unit 7? No, it was Unit 6, the one that very few of you passed the first go around. So maybe you know it better now because you've done it twice. I'm hoping you know it better now.
It's funny because Joe used to pass with all, and I doesn't pass anything.
Me? I have that. I failed
We have many meetings.
I retook the contents.
Anyways, you guys agree with this? Or does anybody disagree with that? Aren't those the same? So the trick is to get rid of the radical sign and use a rational exponent, because logarithms play great with exponents. They're friends, but not with radicals. So I'm going to rewrite the square root as the log base 2 of x squared, and then the yz is going to have a power of 1/2, like that. Exponents are much better to use with logarithms than radicals. You see what I did there? Why did the 1/2 have to go to both the y and the z? They're both under the root there. Right. Welcome back. For next year? For this year? So I would now take this 1/2. You guys see how it's not outside of the parentheses, so you can't put it down in front.
Wait, so where did the 1/2 come from now? Oh,
Well, a square root is the same as a power of 1/2. Those are the same thing
the square root is?
as a power of 1/2.
Yeah.
So like on your problem, don't you guys have a cube root? Well, that's just the power of 1/3. Those are the same thing. So I'm going to take this power of 1/2 and apply it to the y and the z. So now I have the log base 2 of x squared y to the 1/2 z to the 1/2 x squared. And now, since there's a multiply between what expands all of those? Addition. And then once you've done that, where do all of these exponents go? To the front. So the answer is going to be that 2 log base 2 of x plus 1/2 log base 2 of y plus 1/2 log base 2 of z.
No, that's not.
Not really. Now, we're going to take off in just a few minutes. The other half of the lesson is doing the exact reverse of what we just did. It's putting things back together. For example, what if we had started with this? No. What separates all of them?
Plus.
So what does that mean happens when you put them all back together again?
It'd be
They don't be multiplying each other. And where do all of these numbers here come from?
the exponents.
So you put them back up as exponents, and then you condense everything back together. So students actually have an easier time putting it back together from what I've seen. They tend to have an easier time putting it back together because you just go in reverse. The first thing I would do is move all those exponents back up, and then put it back together again. So let's actually choose one from your homework to do together from the condensing section. Let's do
Before it to
if you put 1/3 in front of something, that's the same as dividing it by 3. So yeah. Well, how about, I don't know, 20? You guys want to take a look at 20? Twenty starts as log base 4 of u minus log base 4 of v. Before you can actually put them together again, you got to move all the numbers back up top. Like this 4 right here, it's got to go somewhere. Where does it go? Goes back up. So it's log base 4 of u to the 4 minus log base 4 of v. So now that you've taken care of that, now you can condense. Because there's a minus sign between them,
divide.
we're going to divide. Now, here's what I do see students do a lot, and it makes me feel bad to mark it wrong. Actually, you guys tell me the problem with this. I see this answer on tests every year. I see this.
No. No. Whoa, no.
I see this all the time. I understand why students do it. I do. I really do. Because what does subtraction mean?
Divide.
It means you're going to divide, but the problem is, you guys listening carefully, condensed means one logarithm. If you condense things into a single logarithm, here we have 2 logarithms. So this is completely different than what the answer is supposed to look like. You condense it into one logarithm with a base of 4, and then you divide what's inside the logarithm. So what's really supposed to divide?
U to the 4 over v.
And that's what the answer should look like. Yeah. Now you guys, 23. Are you guys looking at 23? Here's one that looks like it, and once you see the trick, you'll know that's done.
23.
That's not like 23. Where'd you go? This one here. This kind of looks like 23, right? These dividing by 3 sometimes will throw students off. But dividing by 3 is the same as timesing by a 1/3. You see if I put a 1/3 in front?
Yeah.
Did you guys see where now? Like this here. What if I had x over 3 and then I had 1/3 x? Aren't those the exact same thing?
Yeah.
X over 3 or 1/3 x. So if you're dividing by 3, just call it multiplying by 1/3. Why multiply by 1/3? Well, those 1/3 now come up as exponents. So that's what's happening on 23. Instead of dividing it by 3, multiply by 1/3.
Wait. What exponents?
The 1/3 is going to move back up as an exponent of 1/3.
Oh.
Here and here. The 2 also moves up as an exponent. And since there's an addition sign separating all the logarithms, when you condense it, they're going to multiply. And what are powers of 1/3? A power of 1/3 is really just what?
That's where it's the root.
Cube root. And since both of these have a power of 1/3, they're both underneath the cube root.
Would it be wrong if you wrote cube root y, cube root z?
Graphs? Here's one example that looks kind of like it. Look real quick. Well, mine. Let's say it's going to be the same. You guys listening carefully? The -1.
Gives it down one.
Remember how these, maybe you don't remember, but these graphs have a horizontal asymptote, that dotted line is horizontal. That's where this is the last two questions on your worksheet. That's where this is going to be, -1. So this graph, you'd have a horizontal asymptote going right through -1. Now what's here? It's +2?
Yeah.
So then where would your asymptote be? +2. Now the other thing I had to do was make a table of values. One of the x's had to be 0. Always has to be 0. And then you plug them in. So you choose a couple of other x values in your graph.
And what's 2 plus 1/3?
2 plus 1/3? 2 1/3.